Hi, Duncan Chessel, Managing Director of Copper Search, ASX stock code CUS. I'm joined here today with Ian Warland, our heavy mineral sands expert and principal geologist on that project from today, and he'll be chatting to us. G'day, Ian. How you going?
G'day, Duncan.
G'day, Ian. All right, well, I'm going to just do a little bit of an intro on where we're at as a company. We've obviously just been through a couple of new projects have come in the door, and some exciting news out of the heavy mineral sands, which Ian will speak to later. And then we've completed a capital raise just recently. Some of the numbers on the screen there, latest market cap, the cash on hand last quarterly, obviously plus the capital raise, successful capital raise from last week of $850,000 with a rights issue open for another $500,000 at the moment. So just running through to the our company strategy, where we're at, and how does heavy mineral sands projects fit into the other porphyry copper gold projects that we've got elsewhere in Australia. And really our strategy is to put large scale potential discovery successes in front of the drill bit. Every quarter we want to be out there having a crack at really moving the needle for the share price for investors. What we're doing with that is looking at mostly copper, gold, near surface paleochannel uranium are our main commodities of choice, but opportunistically we'll certainly have a look at something as compelling as and interesting as heavy mineral sands. But who is Copper Search, and how do we think we can get there? And today we're joined with one of our commodity experts, Ian Warland, and we'll talk to some of his amazing discovery successes, including discovery of a world-class heavy mineral sands deposit in the Eucla Basin. But I'll go back across to the board and the exploration team and our commodity exports. Overall, the people involved with this company have had over $100 billion worth of discovery successes in the exploration space and created multiple world-class deposits which are being mined today. So we're very fortunate to have a well-credentialed board, including Tony Belperio, Peter McIntyre, large-scale deposits discovered there, Prominent Hill IOCG by Tony Belperio, HUSAB, uranium deposit in Namibia by Peter McIntyre. Peter sold that for over $2 billion for one example of the successes from our board. The commodity experts, John Main, chairman of our technical review panel, over 40 years in the industry, and the list goes on. Won't get into that too much, but with that sort of team and process in place, that not many other juniors are fortunate enough to have that sort of broad expertise in different commodities as well, is that rigorous selection process and how we go about doing that and evaluating our opportunities, and that evaluation step before we spend shareholders' money on drill targets is certainly a very rigorous process, whereby we have to, as the exploration team, go through all that process with our commodity experts, goes to the technical review panel, and then finally the board has to sign off on it being a good use of shareholders' funds. So we don't go out and drill just our best target on our property. We go out and drill things that are actually worth drilling. We're a little bit choosy on projects, but when we see something we really like, we get in there and we go after it. A little bit about the company history and the Peak Project's origin, which Ian will speak to in a moment, is the company was founded in around 2019 to have a look at the copper opportunity in the Peak and Denison in the far northern corner of South Australia. Is Gawler Craton, an area known for some of the very significant mines which BHP now owns, Prominent Hill, Olympic Dam, Carrapateena, huge world-class IOCGs. And a little bit out of that main corridor was the potential for there to be another set of IOCGs up in the Peak and Denison. The company was IPO'd, raising $12 million in 2021, with a single project focus for discovering another sort of set of IOCGs. And that's certainly something I came into the company in 2022 and have been leading that exploration in that area through that time. Now, we had a couple of discovery, technical successes. Multiple IOCGs were delineated, but of not sufficient grade and at reasonable depth. So it was recommended to start looking for other opportunities. 2024, late last year in September, Petrotherm made their discovery, a heavy mineral sands discovery at Rosewood in South Australia, and it highlighted the opportunity for heavy mineral sands in the Eromanga Basin, which hadn't really been sort of considered so much before. Earlier this year, in 2025, we commenced acquisition and putting in, entering into options and joint ventures in the Macquarie Arc in New South Wales, which is a highly fertile area and has a lot of large-scale deposits in production, very profitable mines in the copper, porphyry, or gold space. We picked up in February the Byrup project, and only a couple of weeks ago the Thesis project down near Cow, a gold and copper opportunity there. Also earlier this year, only not very long ago now, Ian Warland came to us and said, "Look, I think you guys might have a prospective area. I've been following what's going on with Petrotherm, the Eromanga Basin. I wouldn't mind going out and having a bit of a scout around and seeing what you've got. I've got a few ideas." So he conducted a field trip to test for the presence of and obtained grab samples of heavy mineral sands and pan concentrates, and that was announced on the 26th of May. Some pretty auspicious results from those grab samples and staking of a new ALA on open ground, and subsequently some more other opportunities that have been staked like that. So maybe Ian's probably best to might just introduce you, and then hand over to you. But so Ian is our principal consultant on the heavy mineral sands Eromanga Basin of South Australia for Copper Search. And he has been awarded the Explorer of the Year award for he and his team for a ground-up discovery of, it was initially the Jacinth Ambrosia discovery in the Eucla Basin, and then it went on to being a whole series of other deposits in there. Ian, it's probably maybe have a bit of time to chip in and have a bit of a talk to the map and some of these photos.
Oh, thanks, Duncan. Yeah, so thanks for the nice introduction there. Yeah, I spent about 20 years with Iluka, and most of that was in the mineral sands. And a lot of that time was in the project generation group, exploring the world for heavy mineral sands deposits. And yes, the team and I had a great success in the Eucla Basin with Jacinth Ambrosia, which is still being mined today. And there's still over 300 million tonnes of resources, I believe, in the Eucla Basin. Okay, so heavy mineral sands, the clue, of course, is in the title. They are heavier than normal sand, so they have a density greater than 2.8 specific gravity. So that means they concentrate in place of deposits like beach shorelines or even rivers. Now, the main components of heavy mineral sands, the valuable component, are generally the titanium-bearing minerals. So you've got ilmenite, leucoxene, and rutile that are titanium-bearing, and then you've got your zircon as well. So titanium, as we know, is very important. It's a critical mineral, and it's used mostly to produce a titanium dioxide. So it's a feedstock for titanium dioxide production, which is a white powder or pigment that is used in paints and plastics and into cosmetics as well. And also titanium metal, as we know, is used in aerospace, used in defense and in medical implants. So it's a very important critical mineral. Zircon, on the other hand, it's quite a bit different. It's mostly used in ceramics. It can be used in it's got special heat resistant properties as well, and it's very chemically stable. It fetches a very high price because it's also used in foundries and nuclear reactors as well. So basically, the titanium-bearing minerals that I mentioned, ilmenite, leucoxene, and rutile, they fetch a higher price depending on how much titanium dioxide they have in that mineral. So rutile has the highest. It's got generally over 90% titanium dioxide in it, And so you can get $1,100, $1,200 US per ton. And then leucoxene, 400 to 800, and ilmenite, 250 to 340, depending on the level of TiO2 in ilmenite, which can vary. Now, zircon is, you can fetch a much higher price. Zircon is worth about $2,200 US per ton. So it's more beneficial to find a heavy mineral sands deposit that has a higher component of these high value minerals like zircon, rutile, and leucoxene.
The other one on the list there, the monazite, Ian. Perhaps if you could just talk to investors about what is that?
Yeah, sure. So monazite is basically got rare earths in it. So it's a little bit harder to process monazite, and it usually occurs as a sort of small component of the heavy mineral sand suite. But you can see that it is actually a very high value mineral. So if you can find enough of that, you can find a customer that will take that on and be able to extract the rare earths from that monazite, which we know rare earths are critical to the new energy transition, or the transition to green energy, especially. Yeah, so this slide really speaks to the prospectivity of the Peak and Denison area in the Eromanga Basin. And you can see on the diagram there is a little small insert, and there's a green, part of that green extent of the Eromanga Basin you can see there. And in the southern part of the Eromanga Basin is Petrofirm's Rosewood deposit that, as Duncan mentioned, was discovered late last year. Now, there have been workers that postulated that the Eromanga Basin was very prospective for heavy mineral sands. So the Department of Mines here in South Australia have done some work on that. But there hadn't been a lot of exploration for heavy mineral sands. And then when Petrofirm came along and found Rosewood discovery, it really has proven that there could be economic concentrations of heavy minerals in that basin. So armed with that knowledge, and I think, like I've mentioned before, that in many basins, like the Eucla Basin, the Perth Basin, and the Murray Basin in Victoria, these deposits don't often occur in isolation. You'll find many mineral sands deposits in the basin of all sizes and all grades, of course. So it's highly likely that there's other deposits in the Eromanga Basin. But if you want the best chance of finding high grade and larger deposits, because they are a heavy mineral, you do need to find the right trap site. So as an example, in the Eucla Basin, the Jacinth Ambrosia deposits are located near an old shoreline headland or a bay, and the heavy minerals were concentrated in that bay over many thousands, possibly millions of years. So when you look around the Eromanga Basin, going on to this next slide here, the Peak and Denison Ranges really sticks out as a topographic high in that Eromanga Basin. And because it's a topographic high, you can imagine it was like a headland in an ocean, and then there were certain bays or beaches along that topographic high. And that's where it's a good conducive spot for heavy mineral sands deposits to be deposited there. We're pointing out here on the left-hand side, you can see the red circles there. The pink hatching there is what we call the Cadnaoui formation. So there's two main target horizons in the Eromanga Basin that we've identified that we're very interested in. That's the Algebukna formation and the overlying Cadnaoui formation. The Cadnaoui is the one that's probably more of a marine style deposition, and highly prospective for the mineral sands. And we've highlighted some bay shapes there. After we went into the field looking at the EL that you can see on the right-hand side, and we confirmed that there were heavy minerals in the drainage, we then were having a closer review of the magnetics in the area, and we found in the TMI, first vertical derivative, that there were these subtle magnetic anomalies, linear ones, in about the direction, this northwest direction, where is the direction that we would expect strand lines, heavy mineral strand lines on a coastal plain to form. So those magnetic anomalies. They're within the Cadna-Owie Formation. They're within 50 metres of surface, but they're covered by aeolian sands, so younger aeolian sands, and that means we can't see any heavy minerals, particularly at surface in that location, but we do need to ground truth that when that is granted. Now, magnetics has been very useful in other basins, particularly in the Murray Basin, where there's a number of strand lines that are magnetic. Particularly the ilmenite can be magnetic, and that shows up in as an anomaly, and then could be a direct drill target.
Um, our geophysicist Theo Anavanis, who's worked on lots of deposits on lots of different types around the world, he was sort of saying to us as well that this over here on the left-hand image, we've got the strand lines on the left of page in the red hatched area. And that's because the basin is deeper there and there's no other magnetics, deeper, more magnetic susceptible rocks. So you're getting a cleaner image of the near surface. But on the right-hand side, where you picked up the grab samples, we're not seeing any strand lines interpreted over there on the EL6195 because, as he explained, the basement rocks are actually quite shallow. And so it's too magnetically noisy to differentiate it. So are both sides prospective?
They are both perspective, and like in any exploration model, you have a toolkit that you use, and that's geochemical and geophysical and geological, and you use the appropriate tool based on the environment that you're working. So you're right to say that on the left-hand side, where we can see those subtle anomalies, the crystalline rocks are quite deep, and therefore the response has been subdued, which means we can see the subtle responses near surface. Whereas on the right-hand side, we know we do have good grab samples from there, but because the magnetics is so noisy, we're not seeing any sort of response near surface. But it is still as prospective. There is a bay-shaped feature there. There's an old drill hole that we basically had a look at and confirmed that there is unconsolidated sands in the vicinity of those samples that's at least 60 metres thick of unconsolidated sand. So that's very positive. Yeah, so this slide really talks about the process of reconnaissance, and you can see on the photographs there on the left. So we basically go out into the field, we do stream sediment sampling on the available creeks and drainages, and we're looking for any signs of heavy minerals that might be getting concentrated up in that near surface environment. And those heavy minerals have probably eroded from small exposures of the target horizons like the Cadna-Owie Formation or the Arjabukna Formation. You can see the dark minerals sitting there in the creek bed is the second photo down. We then concentrate that up in the pan with water. We remove the lights, the sand and the quartz, and we keep that heavy mineral concentrate. We're not trying to get an idea of the heavy mineral grade or percentage. We want an idea of what are the main minerals, heavy minerals, in that assemblage. So that is representing the mineral assemblage. Is it zircon rich or ilmenite rich or leucoxene rich for that particular area? Those pan cons get sent off to the lab. You can see they get separated in a funnel there after some processing with a heavy liquid. The heavy minerals go to the sink to the bottom, the floats go to the top. You drain off those heavy minerals, and then you have a close look under the microscope, and you can do grain counting, etc., to estimate the percentage of those heavy minerals in the assemblage. And out of the 3 samples that we got from the EL, you can see there's a high value assemblage. We've got 80 to 90% valuable heavy mineral and up to 35% zircon in that second sample. So we're very pleased with that mineral assemblage, which is dominated by high TiO2, ilmenite, leucoxene, and some rutile, and a high zircon component. So that's a really good start for a recon program in this area.
Yeah, I noticed in the table 2 here, ilmenite, altered ilmenite, pseudo-rutile, all the sort of a form of weathered ilmenite, and then 5% of it as rutile. Just could you just talk to what's that sort of process there, and what does that tell you about the conditions that have given rise to that sort of percentage of ilmenite, altered ilmenite, and pseudorutile?
Yeah, sure. So ilmenite, ilmenite is made up of iron and titanium. Okay, so when you have fresh ilmenite that's made in usually mafic rocks, igneous rocks, it might have 50% titanium and 50% iron in it. But over time, as these minerals are exposed to air and to water, they oxidize, or I like to think of it as rusting, and that iron is reduced, and consequently the titanium is increased. So over time, you get altered ilmenite, which means iron is left, and leucoxene, which can have 70-75% TiO2 in it itself. And pseudorutile is on that spectrum of minerals as well. Rutile itself is its own mineral and has a different crystal structure, and it's generally greater than 90%, 95% TiO2.
Thanks very much, Ian, for a great explanation and a great result for shareholders to have identified this opportunity. We look forward to seeing what comes out of the Recon Drill program in a couple of months, and certainly there's that and a lot of other news flow coming up. But thank you very much, Ian, for your presentation today. So we've got quite a bit of news flow coming up, and not just across the Peak HMS or Heavy Mineral Sands project. We're getting out back on boots in ground in June, sampling and mapping on our Granite EL. As soon as that ELA on the left hand side of the range there on the western side is granted, will be out there ground truthing and getting ready with heritage surveys. Obviously submitting drill permits once that's granted, and getting out there with an aircore rig as quickly as possible. Work continues on our Byrot project in the northern end of the Macquarie Arc, a copper gold porphyry and orogenic gold opportunity. We've had field crews out there collecting gravity data over the last couple of weeks, and other teams, geologists out there, boots on ground, field verification of the chargeability anomaly that was recently identified. And then only about a week ago now, the Thesis project secured under exclusive option 6 months to purchase. We're commencing due diligence on that, landowner engagement for a final decision to purchase, and then that's then going into our drill pipeline for late this year or probably early next year, Q1, Q2. So we've got a lot of things going on in the company and a lot of news flow to come. The other thing is we are changing the company name now that we're not a single project, single commodity focus to Altitude Minerals, and that'll be done at the next general meeting of shareholders, or put to shareholders for a decision. The pipeline of targets, New South Wales and copper projects, I'll talk to those just quickly because a lot of this talk has been about the new heavy mineral sands opportunity, and certainly we really believe that can move the needle for shareholders in a very quickly. The project secured in May 25, the Thesis project, down positioned over here on the image on the left hand side of the screen. You can see the orange tenement there that we staked ourselves. That's in application, and then the red 3 tenements there that was Rimfire Resources have given us an exclusive 6-month option to purchase outright, with some pretty decent, significant drill intersections of gold, 20 metres at 0.73, 36 at 0.43, all from pretty shallow, from 6 metres, 48 metres, another decent intersection from 22 metres. And there's also been one deep drill hole in that area, and they hit an epithermal vein down at 700 or 800 metres, another high-grade vein, but nothing tested in between. So we think there's a big, large exploration space that's untested potentially for high-grade gold. We're in a very well-endowed area there, the Cow Gold Mine, Evolution Mining, 8.9 million ounces in depleted resource. North Park, again owned by Evolution, 2.6 million ounces of gold, 3 million tonnes of contained copper, depleted resource, etc. So in the Macquarie Arc is Australia's premier copper gold porphyry systems in that Lachlan Fold Belt across towards Sydney there. The other project that we secured earlier in the year, the Bairoch project, is up in the northern end. And again, we went through that selection criteria. Are there profitable mines in the same geological domain? Has it got large scale potential? Do we understand the mineral system? Porphyries, yes, they're well sort of fairly shallow, etc. It goes down the list. Great jurisdiction, cost to work up, drill targets, etc. So we put our foot on that with an option to commence a joint venture over a number of years. And in the appendix, there's the deal terms on that. But where that sits in relation to the new Theseus project, Bairoch is in the top left here, on what we're interpreting as to being the northern extension of the Macquarie Arc, or the Junai Narromine volcanic belt of the Macquarie Arc. And that's where we've got these targets here, T55, T47, the porphyries there, and also a chargeability anomaly located just in here I'll talk to in a moment. We did put out some geophysics update as an ASX release with exploration results on the 7th of May. And this is just looking at the Bairoch project itself. Again, T55 on the right hand side of the page looks like a porphyry. We've been conducting gravity, we trialed IP over it. Unfortunately, a little bit too much clay cover for the IP to be effective, and we had a little bit of trouble with the IP survey up here. It was only sort of 50 to 80 meters of cover, but again, not sort of a clear decision on what's going on there. So some more work to go. But the IP was effective down here at CSO3, where we identified a chargeability anomaly. And that was fairly shallow at 120 meters depth there. So Prospect CO3 is a Cobar style system, probably a polymetallic. And at the northern end of that line, we detected a chargeability anomaly on a fault, a great place for mineralized fluids to come up and to be trapped. The chargeability anomaly identifies where there's sulfides and metal sulfides, and that is being followed up through ground truthing, some more soils across the top of that, and a decision whether or not to extend IP sort of east and west along on that area will come up from that. In the appendix here, there's deal terms on the New South Wales projects. I won't go into those now, and some more details on some of the board and the exploration team's credentials and a longer form of their CV in there. But look, thank you very much to shareholders who participated in the recent capital raise. Those of you who are considering the open rights issue, and you are a shareholder, obviously, to have received the offer, I urge you to take up your rights. We have a significant number of drill targets coming up and a very busy and exciting back end of 2025, and any one of these 3 projects that we're working on to bring drill targets forward could significantly move the needle, and we've now secured sufficient funding to really kind of get in there and give it a good crack. So thank you for your time today, and again, if you want to join up to our newsletter, have a look at our website, coppersearch.com.au, and join our newsletter to receive some updates from the company. Thank you very much.